If you need to multiply some number from 1 to 10 by 9, you don't need anything but your hands. Place both palms before you and assign each finger a number, just like shown on the screen. If you need to multiply 3 by 9, bend finger number 3. On the right, you still have 7 unbent fingers. That's the first part of the answer. On the left, only 2 fingers are left unbent, and that's your second part. Voila! 9 times 3 equals 27. While in the previous example we could only multiply the first 10 digits by 9, now we'll do this trick with just about any number, and it's easy as pie. Take any random large number, like 1,250. Multiplying it by 9 in a conventional way without a calculator would take you some time. To make it simpler, just add a 0 at the end and subtract the original number. That makes it 12,500 minus 1,250 and equals 11,250. That's how quick it is. Now, let's take it a step further and learn to multiply any large numbers between each other. For this, we'll use a method taught in Japanese schools. Let's take 12 multiplied by 31 as an example. In this method, the numbers multiplied are represented by tens and ones. 12 will be 1 10 and 2 ones, and 31 will be 3 tens and a 1. Now, take a piece of paper and some colored pencils, ideally 4. We'll draw the numbers, making them visual. First, draw one diagonal line, left to right, going up. It will represent 10 in 12. Take another pencil and leave a gap below. Draw 2 more diagonal lines in parallel to the first one. This is our 12. For number 31, we'll draw some more diagonal lines. Only these ones will go in the opposite direction and cross our original lines. So, it's 3 lines left to right, going down, for 3 tens, and 1 more line with a gap above the first 3 for a 1. Don't forget to use differently colored pencils as well to avoid confusion while you're still not used to this method. Now you have a diamond shape made of intersecting lines. To calculate the result, count the times all the lines cross each other at each corner of the diamond and write down those numbers at each intersection. You should have 3 at the left corner of the diamond, 2 at the right corner, 1 at the top, and 6 at the bottom. Leaving the side corners alone for now. Add the top and bottom values together. That'll be 7. And if you now divide the diamond shape into 3 parts with vertical lines, you'll get your desired result, 372. There's a catch though. If you're trying to do it with numbers ending with 5 ones or more, you might get double-digit results when counting the intersections. So let's see how to deal with those, taking 25 multiplied by 37 as an example. So we draw 2 diagonal lines for 2 tens, and 5 more for 5 ones. That's 25 for us. Now there are 3 crossing lines for 3 tens and 7 more for 7 ones, and there's our 37. Now we count the dots, 6 at the left corner of the diamond, 35 at the right corner. The times table will help you out a lot here to make it quick. Just multiply 5 by 7. 14 at the top and 15 at the bottom. A lot of double-digit numbers here. First, let's add the top and bottom results as we did last time. 14 plus 15 equals 29. Now we have 6, 29, and 35. Take the rightmost number and only leave the 5 in it, transferring the 3 to the middle number and adding it to the sum. You'll get 6, 32, and 5. Do the same with 32 now. Only leave the 2 and transfer the 3 to the left. Add it to the 6 and voila! You've got your answer. Check yourself with the calculator if you want, but 925 really is the correct result. And finally, the same method can be applied to even larger 3-digit numbers. Let's take 322 multiplied by 14 as an example. First, we draw 322 just as we did previously. Only now the hundreds are a separate set of diagonal lines. There will be 3, 2, and another 2. Next, add the crossing lines of 14, 1, and 4. You can see now we have not 3, but 4 sections, so let's count the dots. That's 3 in the leftmost section, 12 at the first top, 8 at the second top, 2 and 2 at the first and second bottom intersections, and 8 in the rightmost section. Adding the first top and bottom dots, we get 14, and adding the second ones, we get 10. And the result is 3, 14, 10, and 8. And now you already know what to do. Transfer the 1 from 10 left. Add it to 14. Then transfer the 1 from the resulting 15 left too. And here you go. 4,508 is your answer. The multiplication table ends with 10, and most people end up memorizing it sooner or later. But there's also a way to take it a step further and learn to multiply by 11 just as quickly. Let's take 34 as an example and multiply it by 11. First, separate the digits, making it 3 and 4 with a space between them. In that space, put the sum of these two digits. 3 plus 4 equals 7. That's your answer, 374. With some numbers, addition may result in a two-digit number. That's the case with, say, 87. You'll get 8, 15, and 7. To get your actual result, add the first digit and the tens place of the sum, leaving the ones alone. That will be 8 plus 1, 5, and 7, which results in 957. If you know the multiplication table well enough, finding out percentages will be a piece of cake. The only downside of the following method is that it can only be used with round percentages of round numbers. But hey, that's already something. So if you want to find out 30% of 80, you just need to ditch the zeros and multiply the tens places of these two numbers. 3 multiplied by 8 will be 24. Same can be done with any rounded percentages and numbers. 60% of 30 will be 6 multiplied by 3, equaling 18. Now let's get back to simple multiplication again. We've covered multiplying by 11, but what about 15? Let's try it with multiplying 64 by 15. First, add a 0 to the first number, making it 640. Now divide it by 2, resulting in 320. And next, add the two numbers you've got. 640 plus 320 equals 960. You can verify it using the calculator, but the principle is easy to grasp. You first multiply your number by 10, then multiply it by 5, which is half of 10. Get it? And add those numbers. A similar method applies to multiplying any number by 20, 30, or any other round number. Let's say you want to multiply 41 by 30. First, add a 0 to your number, making it 410. Now, multiply it by 3, and you'll get 1,230. In fact, multiplication basically boils down to a number of additions performed in a row. Let's try multiplying 16 by 9. 16 is 2 times 8, which converts our task into 2 times 8 times 9. Since 8 times 9 will be 72, we just need to add 72 with another 72, which gives us 144. Let's take it up a notch and multiply two-digit numbers between each other, say 18 times 12. We can unfold these two numbers as 2 times 9 and 2 times 6. Next, multiply 9 and 6, resulting in 2 times 2 times 54. One step further and we get 2 times 108, which leaves us with 216. Subtracting can also be a headache with large numbers, but there's a simple trick to subtract any three-digit number from 1,000. Let's take 578 as an example. What you need to do is subtract the first digit from 9. 9 minus 5 equals 4. Now subtract the second digit from 9 as well. 9 minus 7 is 2. And finally, subtract the third digit from 10. 10 minus 8 gets you 2. Now, place your results together. 422 is your answer. The number of pi is infinite, and the digits after the point go in a seemingly random order, but there's a simple technique to memorize the first 6 of them. Say the phrase, "How I wish I could calculate pi," out loud or write it down. Now count the letters in each of the words, and you'll get the 3 and the first 6 digits after the decimal, 3.141592. You can multiply large numbers between each other in your head easily, but take note that this trick only works with numbers in the 90s. So let's say you want to multiply 93 by 96. Subtract either number from 100, getting you 7 and 4. Now add the two results, getting 11, and subtract it from 100 again, receiving 89. This is the first part of your answer. For the second part, multiply these two numbers instead of adding them. 7 times 4 equals 28. Put it next to 89 and your answer is just that, 8,928.